Okay, this is from section 2.6, number 23. dy dx is equal to 2y over x minus x squared y squared. Okay, so this is another example of a Bernoulli equation. And the formula for Bernoulli equation again is okay. So again, it's very similar to a linear equation. The only difference is this y to the n power. Okay. Okay. So we have to change this up a little bit to make it reflect the Bernoulli equation formula, right? Okay, so now it looks more like a Bernoulli equation, right? You got your p of x here, q of x is negative x squared, and your n is equal to 2, right? So n is equal to 2, and you're going to want to substitute, so v is equal to y to the 1 minus 2, that's going to be y to the negative 1. Okay, and if you want to take the derivative, dv dx is equal to negative y to the negative 2 dy dx. Okay, and again, we're going to use this to substitute later on. Okay. So what you want to do with this now is you want to divide everything by y squared, right? So you can get rid of it on this side. Okay. And this is where you start to substitute, right? So this y to the negative 2 dy dx, you can see that it's actually equal to negative dv dx, right? From the substitution. And then y to the negative 1 is equal to v. So now it's almost a linear equation. All we gotta do now is multiply everything by negative 1, right? To get rid of this negative sign in front of dv dx. Okay, nice. So now everything is positive, right? Now it's a linear equation. Right? And you remember a linear equation, you had to find, so a linear equation is set up like this. And remember, you had to find that integrating factor, which is going to be e to the power of the integral px dx, right? Okay. So our p of x is equal to 2 over x, right? And then the integral p of x dx is going to be 2 ln x, or ln x squared, right? And then our integrating factor nu of x is going to be e to the power of ln x squared, and that comes out to x squared, right? So you take that x squared and you multiply this linear equation, everything by x squared, right? Okay. Okay. And now this is ddx Vx squared, right? Because if you took the product rule, these two things, right, it's going to be x squared times dv dx, and then this part is going to be 2x times v. Okay, so now I'm just going to rewrite it. Okay, and now you want to take the integral of everything, both sides. Okay. Okay, and we're almost done. Now we just want to take, we want the answer to be in terms of the original dependent variable, right? So v was equal to y to the negative 1, or 1 over y. So 1 over y is equal to okay, you can leave your answer like that if you want to, or if you don't feel good about that, you can do this. You can also use that as your answer.